I'm Mr. B Math, and today we're going to talk about how to find the vertex of a parabola or the vertex of a quadratic. That sounds scary. All we're talking about is some kind of y equals x squared equation. When it's an x squared equation, it's going to be some type of u, something that looks like this, okay? And the vertex is just the turning point of it. It's just the lowest point of it. The reason why it's called a turning point is because and we'll see it, not just in theory, we'll see it. This is also a parabola, just a negative, it's just upside down. And this is the vertex of that. So it's either like the highest or the lowest point. It's the turning point of the parabola. But normally you see it as like the lowest point because that's the default x squared. Cool, so that's what the vertex is. How do we find it? First it starts with an equation, y equals x squared minus 6x plus 8. Okay, again, I don't know what this looks like. I just know it's some kind of u. And I want to find the lowest point of it, or the highest point of it, depending on what it is. To find the vertex, it's always negative b over 2a, always. And again, it's just like the quadratic formula, which I hope you're familiar with, where the a is the number right in front of the x squared, the b is the number in front of the x, and the c is the number at the end. So in this situation here, my b is negative 6, and my a, there's no number there, but it's secretly a 1. I take my b, I take my a, I plug it in. Negative 6, that's a little silly, all over 2 times 1. Negative 6, that just becomes a positive 6. 2 times 1, that's 2. 6 divided by 2, that's x equals 3. This should be x equals 3, right? If I have a better math teacher, I put it there. It's always x equals, because this is what this is going to give me is the turning point. It's going to be the x value of it. So now I know that the vertex has a coordinate of 3. But I have to now find the y of it. Just to recap, I did negative b over 2a to find the x, plugged in my a and my b, solved it, I got 3. Whatever I have in x, I can find the y by taking that x and plugging it back in to the equation. So my equation is y equals x squared minus 6x plus 8. I plug it in, I mean wherever I see an x, I'm going to put 3. Because I just found out that the point that I care about has an x of 3. So y equals, instead of x, I put 3. Instead of x, I put 3. And that's it. Now this is just numbers. You can frankly put this in your calculator, but I don't like those machines. 3 squared, that becomes a 9. Negative 6 times 3, that's negative 18, plus 8. 9 minus 18, that's negative 9, plus 8, that's negative 1. Which means the coordinate of my vertex is 3, negative 1. So I go on my graph, 3, negative 1. Right there is my vertex. In order to best graph this, I should also probably find the x-intercepts. To find the x-intercepts, I'm going to factor this with a and m. I'm going to do it quickly over here. I have another video on that if what I say now, it doesn't make any sense. But to find the x-intercepts, I super quickly set my equation equal to 0. I have 3 things, so I try to a and m. What multiplies to 8? Add to negative 6. I see that that's going to be 4 and 2, because 4 and 2 multiply to give me 8. But in order to multiply to give me a positive 8, but add to give me a negative, these must both be negative. Because negative 4 plus negative 2, that's negative 6, and negative 4 times negative 2, that's positive 8. This is it in factored form, but I actually care about when it equals 0. And when this thing equals 0, x minus 4 equals 0, I could do the math. I know that's x equals 4, because 4 minus 4 is 0. when does x minus 2 equal 0? X minus 2 equals 0 when x is 2. And these now are my x-intercepts at 4 and 2. So I know my parabola looks something like that. To be the most accurate, that's my y-intercept. It should have looked a little bit more. Sorry. This is my y-intercept. I know it's my y-intercept because there's always a number at the end. Number at the end is my y-intercept. And now to be the most accurate, it looks something like that. Really quickly. Negative b over 2a. Found my x. Plugged my x in. Got my y of negative 1. That was my vertex. This was solving a and m to get the x-intercepts, which is going to be a different video. I did it quickly. This is my first example. I got more. The next one I want to do, y equals x squared plus 8x plus 7. Same thing. This is some kind of parabola, some kind of view. I want to find where it turns. So I do negative b over 2a, x equals negative b over 2a. My a is the number in front of the x squared, which is a 1. My b is my number in front of the x, which is 8. It's negative b, so it's negative 8, all divided by 2 times 1. 2 times 1, that's just 2. Negative 8 divided by 2. 8 divided by 2 is 4, but 1 negative, 1 positive makes it negative. So I know my x coordinate of the vertex is negative 4. Cool. Whenever I have an x, I plug it back in to find the y. So my equation is y equals x squared plus 8x plus 7. Okay. I know the x I care about is negative 4, so I take that negative 4 and I plug it back in. Y equals negative 4 squared plus 8 times negative 4 plus 7. Again, if you wanted to, you could just put that all right in your calculator and it does it for you. I'm going to do it out manually. Negative 4 squared, that's negative 4 times negative 4. That becomes 16. 8 times negative 4, that's negative 32. Plus 7 stays plus 7. 16 minus 32, that's negative 16. Plus 7, that is negative 9. Which means my vertex coordinate is negative 4, negative 9. All the way down there. I know my y-intercept is plus 7, all the way up here. So somewhere here is going to be my x-intercepts. To find my x-intercepts really quickly, I set this equal to 0 equals x squared plus 8x plus 7. I need to A&M this. What two numbers multiply to 7 add to 8? The only two options to multiply to 7 are 7 and 1. And in order to get a positive 8 out of that, they both got to be positive. But again, that's my factored form, what I want on my x-intercepts. My x-intercepts are when x plus 7 actually equals 0. Or when x plus 1 actually equals 0. And I see that when I do this math, I get x is negative 7 and x is negative 1. So I put a dot at negative 1 and a dot at negative 7. I connect my dots in some kind of U shape. And that's how I graph my parabola. It's negative b over 2a, which sounds crazy. How are you ever going to remember that? The way you remember that is because you remember the quadratic formula. And if you don't remember the quadratic formula on any kind of regents, and most tests, your math teacher normally will give you the quadratic formula. So, if you're given the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This negative b over 2a is actually the part that's not included. Like if you ignore this plus minus and the square root and all the ugly parts of the quadratic formula, to be honest, this looks terribly messy, but you're left with negative b over 2a. And that's one way that can help you remember that. I got another one I want to do. I want to do y equals 3x squared minus 6x plus 1. So, this one is a tiny bit more difficult. You might, to find the x-intercepts because there's a 3 in front of my x squared. But the vertex is kind of the same thing, it's nothing crazy. So my vertex is x equals negative b over 2a. Plug in my a is 3 this time. Plug in my b, which is negative 6. I do negative b, which is negative 6, all over 2 times 3. Negative 6 is kind of silly. That's just 6. 2 times 3 is 6. X equals 6 over 6. That's just x equals 1. So my x coordinate of the vertex is 1. To find the y, I just take that 1 and I plug it in. Y equals 3x squared minus 6x minus 1. Wherever I see an x, I put a 1. Y equals 3, 1 squared minus 6, 1 minus 1. All I did was replace the x with the 1. So that's what the x was. 1. 1 squared becomes 1. So that's just 3 times 1, which is just 3. 6 times 1 is, well, negative 6 times 1 is negative 6. And the minus 1 stays. 3 minus 6 minus 1. 3 minus 6 is negative 3. Minus 1, that's negative 4. Same signs, and keep the sign the bigger number. I also got a video on that. So my answer is 1, negative 4. 1, negative 4. Now, if I wanted to find the x-intercepts for this equation, I'd have to do the quadratic formula for all of this. I know I have to do the quadratic formula because my a isn't 1, and I can't easily divide out everything by 3 because 1 can't be divided by 3. So I'm not going to go crazy with that. I just know it looks something, my y-intercept is 1. It looks something like this. The other thing I got to say that your teacher or I might talk about is something called the axis of symmetry. The axis of symmetry is really fancy. Symmetry means you can cut it in half, it's the same on both sides. Think the butterfly, cut it in half, same on both sides. Or think your face is supposed to be symmetrical, cut it in half, same on both sides. Axis just means line. So it's line of symmetry. And this is some kind of U, and I didn't draw it great, but if you draw a straight line down the middle here, this looks terrible on this one actually. I'm going to redo this whole drawing, so it should look better than that. Well, one more try. Sorry. Either way, you're going to trust me. This vertical line right down here is supposed to cut in half. I'm doing a terrible drawing of it, but you can kind of see how it can cut it in half. So this line is called the axis of symmetry. What is that line? That line is always equal to x equals, because it's a perfectly vertical line, x equals 1. It's x equals whatever the x coordinate of the vertex is. So the axis of symmetry is always just x equals whatever the x coordinate of the vertex is. Sounds really complicated. It's just the line that cuts it in half. If you just want to get it right at any test, it's always just find the vertex, and it's always x equals whatever the x coordinate is, and it's always what it is. I got one more I want to do here. I have y equals negative x squared minus 4x plus 5. Minus 4x plus 5. Now, the reason why I wanted to do this one here is because now I have a negative x squared, which is kind of scary, but all that means is my u, instead of being like this, is going to flip upside down and make some kind of n. But my steps stay the same. X equals negative b over 2a. I got to find the a, find the b, find the vertex. My b is this negative 4. My a is negative 1. That's important because there's a secret negative 1 in front there. Plug it in, negative, negative 4, all over 2 times negative 1. Negative, negative 4, that's silly, that's just 4. 2 times negative 1, that's negative 2. 4 divided by negative 2, that is negative 2. Once I have my x, I plug it in to find my y. I could just calculate this whole part. I'm going to do it out the slow way. Y equals negative x squared minus 4x plus 5. This is a tiny bit tricky. Y, again, I'm just replacing the x with the negative 2. Negative 2 squared minus 4 negative 2 plus 5. Replace the x with negative 2, replace the x with negative 2. Now, negative 2 squared, that's positive 4. But this negative in front still matters. So it's y equals negative 4, because this would have been positive 4, but that negative in front made it negative. That becomes positive 8 here, because 2 negatives make a positive, plus 5. Negative 4 plus 8, that is 4. 4 plus 5, that is 9. My vertex is negative 2, 9. Which looks really high for a lowest point, and it's not my lowest point because it's actually my highest point because it's upside down. It's worth finding the x-intercepts here. To find the x-intercepts, I want to do A and M, but I can't really do A and M yet because I have this negative in front of this x squared. But it's not. It sounds scary, it's not. All I'm going to do is take everything on this side and move it over to the left side. How am I going to do that? The same way I normally move over things. So this is a negative x squared. I want to get rid of it from this side, so I add x squared. And if I add x squared on this side, it cancels out. I also add it back over here. It just becomes 0 plus x squared equals negative 4x plus 5. Now my x squared is positive. I'm going to do the same thing with the 4x. Plus 4x plus 4x. Very importantly, x squared and plus 4x don't combine. So it's just x squared plus 4x equals 5. I want that 5 out of there. It's a positive 5. I subtract 5. Subtract 5. X squared plus 4x minus 5. And that whole thing now equals 0 over there. And now I can A&M this, because now my x squared is positive. I need two numbers that multiply to negative 5, but add the positive 4. X equals 0. 5 has to be 5 and 1. And then in order to add to a positive 4, but still multiply to a negative, I know one must be positive, one must be negative. And the bigger one must be positive, because it stays positive. Set both of these equal to 0, x equals negative 5, x equals 1. And these really quickly, negative 5, positive 1, are my x-intercepts. And when I connect my dots here, this should be a little more round up top, but you're going to bear with me. This is what my parabola looks like. And again, my axis of symmetry is just x equals whatever the x coordinate is. In this case, negative 2. I talked too long. Hope that made some sense. Negative b over 2a, that's the vertex. Find the x, plug it in to find the y. That's the turning point of the parabola. Hope this helped.